Screen is visible?
Yes, sir.
Right, okay. So today we will discuss about the next case. Last case we have discussed about the semi-infinite beam with concentrated load. Now today we will discuss about infinite beam with concentrated load and the moment. So next, write down please heading, infinite beams with concentrated loads. First we have to discuss about concentrated load, then we will consider separately about the moment. Please write down the heading, semi-infinite beam with concentrated load. Semi-infinite beams with concentrated load. First we have to consider separately concentrated load, then we will discuss about the moment. So we have to use the previous equations of the deflection, slope, moment, and the axial force. Wait for 1 minute. Okay, I'm audible?
Yes, sir.
Right. Now, whatever the equations of this deflection, slope, moment, and shear force, Okay, that we have to use again once again. Whatever the equations that we have used for the semi-infinite case. Now we are discussing about infinite case. Okay, we are discussing about the infinite case. So for that, or for this case, we have to use the equation of semi-infinite. What we have taken in case of semi-infinite, okay, at origin we have applied the concentrated load, and from origin towards the right side we have taken, okay, that is infinity. Now for infinite case, from origin towards left and towards right. Now for say for infinite case, for infinite case, okay, from origin towards left and towards the right, we have taken infinity for infinite case. So for that, previous case, that is semi-infinite case, we have some equations already we have derived about deflection, slope, or then moment and shear for semi-infinite. So suppose this is considered for the right side portion. Okay, this is origin. Okay, this is for right side and this is your left side. Now, suppose we have considered this is for right side. Same is applicable to the left side, but ordinate is minus x, here it is positive x. Yes or no, correct? Origin पासून right side ला positive x आणि left side ला negative x. बरोबर?
Yes, sir.
Right.
Yes, sir.
So that is case we have to consider. Now for right side case, we have some equations already we have derived for deflection, slope, moment, and the shear force. So we have to consider these equations, and if you're taking for the left side, then we have to apply the minus sign. Okay, so we have to use these equations for infinite case. These are the equations for semi-infinite case. These are the equations for semi-infinite case. We have to use the equation for this for next case, that is for infinite. Right? Now, first we have to consider the case concentrated force for infinite beams. So uniform beam, right? This is the beam. At origin, we have applied the load P naught, right? Now, from origin, we have to extend to infinity towards right and towards the left side, that is in both direction. So whatever the loading force P naught at which is applied at x equal to 0, that is origin. Okay, we have to consider moment separately. So deflections, whatever the deflection, that is W or delta or y, are symmetric with respect to the z axis, and each half of the beam carries half of the load, right? This half beam is carry the 50% load, remaining half will carry the 50% load, right? So the solution for deflection, slope, moment, shear can be obtained from the equation 5.3. Okay, 5.3 equation as I have shown. Okay, here, right? These four equations. These four equations we have to use now: 5.3.3, 5.3.4, 5.3.5, and 5.3.6. Okay, and we have also refer the table. Okay, you can see the value of beta x. It is 0. In terms of the pi, we have to consider the value. If you refer the table, 0, pi by 4. Okay, that is if you have to consider beta x equal to suppose 0. So x equal to 0 by beta. If you consider x equal to, sorry, beta x equal to pi by 4. Beta x equal to pi by 4. So x equal to pi by 4 beta, right? Like this, we have to consider the value of beta x, and then we have to consider the value of x from beta x. If the beta x equal to pi by 2, so x equal to pi by 2 beta, or right, like this. So depending upon the value of beta x and A beta x, B beta x, C beta x, D beta x, which are the values in the equation of your semi-infinite case for deflection, slope, moment, and shear. You can see here in the semi-infinite case, we have derived the equations. In that case, you can check d beta x, c beta x, a beta x, b beta x, etc. So for these values, we have to consider the value of beta x, right? So for this, you can see here now at 3 pi by 4, 3 pi by 4, beta x equal to 3 pi by 4. So x equal to 3 pi by 4 beta. That is the value. So that is the from table we have taken. That is for deflection. For slope, we have to consider x beta x equal to pi. For moment, we have considered the values. Okay, pi by 4 or pi. Okay, and for shear, it is like this. Okay. So this value from the table we have to consider. So what are these curves? First is the load, then B to E. All the curves are for deflection, rotation, bending moment, shear in the beam, and these curves, or to whatever these curves are, proportional to these values: A beta x, B beta x, C beta x, D beta x, which is we have seen in the table, right? Now now, whatever the P, whatever the load P is replaced by P naught by 2, because the right side we have considered 50% load, and for left side we have considered the 50% load, and the moment is m naught. Okay. So like this, we have to consider at theta is equal to 0, when x equal to 0. Okay, x equal to 0, rotation or the slope is equal to 0. So by considering this, the equation of theta, the equation of theta, right? What is the equation of theta? Equation of theta is minus 2 beta square p naught by k a beta x plus 4 beta cube m naught k by d beta x. So p naught is replaced by p naught by 2, right? P naught is replaced by p naught by 2, and x equal to 0. X equal to 0, right? So depending upon the values of table, okay, now theta is 0. So by putting the values, we get m naught is equal to, in terms of p naught, m naught is equal to p naught divided by 4 beta. Okay, m naught divided by 4 beta, right? 1 beta get cancelled, then k get cancelled, then 2 get cancelled. So remaining is m naught is equal to P naught by 4 beta. So this is the value of m naught. Now, substituting the value of P naught by 2 and m naught is equal to P naught by 4 beta in the equation of theta, okay, in the equation of theta, okay, and using the different equation, we have to find out the value of deflection, slope, moment, and shear. Now, this is the equation of deflection. If we have to refer the equation previously, that is for semi-infinite case of the deflection equation. Now you can see here, this is the equation of W at x equal to 0, at x equal to 0, right? At x equal to 0. So if you refer the table at x equal to 0, what are the values of d beta x and c beta x? You can see here at x equal to 0, c beta x equal to 1, d beta x equal to 1, right? So whatever the equation of c beta x, d beta x, you can put the value of beta x equal to 0, you get the value of c beta x and d beta x equal to 1. Now this value we have to put in the equation of deflection, W, and P naught is replaced by P naught by 2 and M naught is P naught by 4 beta. So by putting the values, we get the value of deflection, W is equal to P naught beta by 2k into a beta x, then theta is equal to derivative of this with respect to x. So we get theta is equal to minus beta square p naught by k d beta x. Now double derivative of w. So p naught is equal to 4, sorry, p naught by 4 beta cbx, c beta x, and v is equal to shear force is equal to triple derivative. So shear force we get minus P naught by 2 d beta x, minus P naught by 2 d beta x. So these are the values of your deflection, slope, moment, and shear for infinite beam with concentrated load. Infinite beam means on both sides from origin we have to consider the value of x is up to the infinity. So for this case we get the value of slope, deflection, moment, and shear. Okay, by putting P naught is nothing but P naught by 2, and at x equal to 0, theta is 0. So by equating 0, for semi-infinite case, we know the equation of slope. In that equation, we can put the value of theta is equal to 0, and c beta x, d beta x, whatever the values, depending upon that, we get the value of m naught, and that value we have to put in the equation of w from the previous case and take the derivative one time, two time, three time, we get slope, moment, and shear. Okay, so please write on the heading. Please write on the heading. Heading, write on infinite beams with concentrated loads. Infinite beams with concentrated loads. Write on the heading, infinite beams with concentrated loads. Now, please draw this all diagram. Please draw this all the diagram. Diagram is over. Diagram is over.
Sir, wait.
Okay. Please write on the description which is below the diagram also. After finish, please inform.
Completed, sir.
Completed. Okay.
Yes.
Boys?
Just a minute. Just a minute.
Okay. Okay, shall I proceed? Dhala?
Yes, sir.
Okay. So write down these equations, only equations. Write down these equations for W, theta, M and V, deflection, slope or rotation, moment and shear. Now, as far as we have discussed, that is left side and right side. Okay, right side positive, left side negative means x is greater than 0 and here x is less than 0. So like that, we have to consider the okay cases. So that is equation that is applied for in this case infinite beam that carries concentrated downward force at x equal to 0, right? So whatever the equations in these equations, x must be 0 or positive. Okay, condition in the left half, x is less than 0 must be obtained from the calculation in the right half, that is x is greater than 0. Okay. Dhala? As we discussed, that is left side, right side. We have to put the value of x is negative for left side. These signs are as it is. Write on this statement and this line. And on below that, below this equation, conditions in the left half